Hello everyone, my name is Nathan DeCaza, and today I will be presenting my project on predicting student GPA with using advanced data analytics within RapidMiner. So this project aims to develop a predictive model that can accurately estimate the grade point average, or GPA, of high school students based on a comprehensive data set. So by leveraging these machine learning techniques that we've learned throughout the semester in RapidMiner, this model provides actionable insights that can help educators and policymakers enhance educational outcomes. So kind of just imagine a world where we can see all of these different stats that these students have. So whether or not they've been getting tutoring done after school, whether they read or not, whether they do extracurricular activities, and be able to see how that affects their GPA throughout the school year. And then we'll be able to tailor our teachings to the student. So that's kind of what I thought of when I saw this data set on Kaggle. I thought it would be a cool opportunity to see what different characteristics a student has determines, what GPA they'll have. So let's start with a brief overview of what we'll cover today. So first I'll introduce the research question and its importance. Then I'll walk you through the data exploration process and the steps involved in data preparation. Then I'll discuss the modeling techniques used, the evaluation of these models and the results, and then finally we'll look at a deployment plan and conclude with key findings and implications of this study. So the primary research question pretty much is, how can we accurately predict the GPA of high school students? So the sample data set that I got from Kaggle had a list of, like parental involvement. So whether the parents were involved in their studies, extracurricular activities. So if they got involved with like robotics or something like that, and then academic performance, how that all affected their GPA or their standing within the class. So accurately predicting the student GPA is crucial because it allows educators to identify at-risk students early and implement timely interventions. So say there's a student that doesn't have like any of these key indicators that were within the study. They were absent a lot. They didn't do extracurriculars. They weren't doing tutoring sessions. They weren't reading books, stuff like that. You guys can kind of see that and determine whether or not these kids will be at risk, and kind of tailor a more appropriate learning session for that student, instead of just seeing that they have bad grades and then kind of getting mad at them because of that, and not really seeing the underlying cause of why they're getting bad grades. So this sample set kind of gives identifiers for these students and allows us to predict the GPA of that student. So this can significantly improve educational outcomes by providing personalized support to students who need it the most. Additionally, understanding the factors that influence GPA can help in developing targeted educational strategies and allocating resources more effectively. So again, if we see a student that doesn't have all of these key indicators of a high GPA, and they maybe have indicators of a lower GPA, we can kind of start to tailor our teachings toward that student more effectively, so that they're able to better or more effectively be involved within school, within the community, get that higher GPA, which will get them into a better school, or get them scholarships to go to that school. So the data set used in the study is sourced from Kaggle, and it consists of 2,392 high school students that the individual collected over a few years. So it includes, age, gender, ethnicity, parental education level, weekly study times, absences, tutoring status, parental support, extracurricular activities, participation in sports and music, volunteering, GPA, and grade classification. So really all of these can attribute to higher GPA, as we found in the study. So age, usually the older students will have higher GPAs because they're more mature, they have more knowledge, but that isn't always the case. Gender, that wasn't really factored in. Parental education level, so we see parents with higher education levels, their kids are going to have those higher GPAs because maybe they instill some of their knowledge on their child. Weekly study time, this was a huge indicator of higher low GPAs, as was absences. If the kids are not studying, then they will not be able to get higher grades on the tests or the papers or the quizzes. And then if they're absent from those classes where the teacher is effectively giving you the answers to the tests and the quizzes, then you're not going to have a higher GPA. Tutoring status, this was either a 1 or a 0 for the data set. Were they going to tutoring or were they not? Usually you don't need tutoring unless you have a lower GPA. So this was kind of a in-between indicator. Usually as you start to go to tutoring, your GPA will come up. Parental support, extracurricular activities, so stuff like sports, music, volunteering, and then grade classification as the determining factor of what we're trying to find from this study. So the data set includes both continuous and categorical variables. So like gender is a binary categorical variable. There were either male or female points in the data set. And then continuous variables were things like GPA. So 0.0 to 4.0, with 4.0 being the highest, 0.0 being the lowest. So it really provided like a holistic view of the students' lives and their academic performance. So if we're seeing them, usually if we're seeing them do stuff outside of school, that means they're performing well within school. They have time outside to focus on other things. Like when I was going to high school, I was doing robotics, I was playing soccer competitively, and I really think that was an indicator of me having a higher GPA during those years of my life, because I was able to put more time towards those other things because I was doing so well in that one part of my life. So one important part of when you get any data set is the cleaning and the feature selection. So cleaning involves handling missing values or variables, and then taking away outliers so they're not effective or affecting the data set at the end when we run our processes. So the missing values were imputed using mean and mode imputation, while outliers were identified and just taken out of the data set completely, because those outliers weren't going to help our model process evaluate whether or not these indicators affect the GPA of individuals. Next was feature selection. So it was performed to retain the most relevant predictors, such as study habits, parental support, and extracurricular activities. We didn't include like things like the student ID, and then we had two indicators that we were trying to really find was the GPA and then the grade standing. So we didn't want to have both of them because they weren't, one was really the definition of the other. So we took out one of those to effectively cancel them out. And then at the end, visualizations, scatter plots, and histograms were used to understand the distributions and relationships. So we use the auto model tool within RapidMiner. So I'll kind of show a little bit of that here. It's a tool in RapidMiner that was used in the last project. So I'm just going to restart, and we use the student performance data, Excel. We imported it into RapidMiner here. We wanted to predict the grade class or the GPA. It doesn't really matter which one you click as long as you cancel the other one out, so they're not affecting the results. So GPA, and then like I said, we want to take out grade class, and then things like age and student ID were red here. So I didn't want to select them because RapidMiner was saying that, okay, they're not going to affect the data at all, really. And then we wanted to see all the models and compare them. So we would run it here, and then it takes a little bit. The results are coming, and we have things like relative error, root mean squared error, correlation, absolute error, things like that on the side that we can select to kind of see the differences with these models. And then once it's finished, we can see the models themselves, the simulator for those models, to kind of do greater analysis and kind of determine what things are affecting the results. So now that it's done, we can kind of see generalized linear model. We can see the simulator to see if we put up the absences, right, the prediction for the GPA is going to go way down. If you have 29 absences versus 0, it's a huge difference in GPA, whereas things like gender, you don't really have a difference between 1 and 0. That didn't really have an effect. And things like ethnicity as well, they didn't really have an effect on the data. But then parental education, if you have more versus less, parental support obviously goes up with the more you have. Sports, study time. So I think what I found was that absences have the most effect. I mean, if you go all the way down, it's 3.3, and then if you go all the way up, it's 0.4. So that has the most effect on the data. So various machine learning models were evaluated. So we use GLM, generalized linear model, deep learning, decision tree, random forest, gradient boosted tree, and support vector machine. Each model has unique strengths, and their performance was compared, just like I showed you within RapidMiner. The models were evaluated using metrics such as accuracy, correlation, relative error, and RMSE, or root mean squared error, and squared error. So the gradient boosted trees model emerges the best performing model due to its highest accuracy and correlation values. And then it effectively captures complex interactions between features, providing robust and reliable predictions. So here are the results to the different models evaluated. As you can see, the gradient boosted tree model achieved the highest accuracy and correlation, making it the most effective model for predicting student GPA. So the evaluation metrics clearly show its superiority in terms of performance and reliability. So integrating the predictive model into the educational decision-making process involves several steps. First, you need to automate the data input. So you're not going to really get the best results if you go around and ask people. It needs to be automated, and it needs to have the latest student data. So if you have data from 10 years ago, it's not really going to be effective at helping students now. It needs to have the latest data for the students in courses now, so you can effectively tailor your education to them. Secondly, generating predictions and storing them in a secure database for further analysis. And then third, developing a robust reporting mechanism using interactive dashboards and regular reports to present the model's predictions and insights. So being able to report this data to the educationers, to the teachers, and say, listen, these are the indicators. You need to make sure that your students know these indicators and they're effectively doing the right thing. So obviously, to maintain the model's accuracy and relevance, it's crucial to regularly update the data set and update and retrain the model. So the data analysis revealed significant relationships between the student attributes and GPA. So things like absences, parental involvement, those sort of things greatly enhanced the GPA when they were all the way to the right, and then negatively impacted it all the way to the left. And then the gradient boosted trees model demonstrated the highest accuracy among all the models. So this study highlights the importance of data-driven decision-making in education. By leveraging machine learning techniques, educators can move beyond traditional methods to more sophisticated data-informed strategies that provide real-time insights and predictive capabilities. The ability to predict student GPA early allows for timely intervention, enhancing educational outcomes and supporting student success. So ethical vigilance is crucial in the implementation of machine learning models in education, because you don't really want to look at these indicators and think badly upon the students. It should be really used as a learning model for determining how you need to teach to these students. So transparency on how the model works and the rationale behind its predictions is also important for getting stakeholder buy-in and ensuring the model's long-term success. Excuse me. So in conclusion, the predictive model developed in this study serves as a powerful tool for enhancing educational strategies. It exemplifies how machine learning can be harnessed to predict and improve student performance, providing timely and actionable insights that support student success. Thank you for your attention, and I'm happy to take any questions that you may have. Thank you for your time.